Hi class, this section is going to be looking at stars, the life and death of stars, how they are formed and what their life cycle looks like. So stars as a definition is a large celestial body that is composed of gas and emits light. Our sun is a typical star. It's not any bigger than, it's just an average size star. It's not any bigger or smaller than other general stars. And most of our stars are put into shapes or constellations. The Greeks grouped a lot of our stars that we can see in our night sky into these constellations because they are regularly in the same spot. Core temperature is more than 15 million kelvins in a star. Nuclear fusion in stars. So stars have their light because of fusion. We talked about fusion back in chapter 9. It takes place in the core of the star. It combines hydrogen atoms fusing together because of high temperature and pressure. Energy from fusion is released as radiation and convection through the star layers. So radiation is light, convection is heat. Light travels at 3 times 10 to the 8th meters per second, and so from the sun to the earth it takes 8 minutes. The light we're getting from the sun is 8 minutes old. Brightness will depend on the star's temperature and the distance from Earth. So those two characteristics will determine how bright a star seems. If it's really close to us, but it's not necessarily a hot temperature, it will still seem bright. If it's really far away, but it's a really high temperature, it'll still seem bright. If it's both, it'll seem really bright. Sirius is the brightest star in our night sky. Star color is related to its temperature, so hotter objects will glow brighter and they have shorter wavelengths, so it's closer to blue. Cooler objects have less intense color and have longer wavelengths, so it's closer to a red. The sun appears yellow because the peak wavelength of the sun is near that color yellow. So our life cycle of a star. A star will look different in the different stages of its life cycle, just like humans look different in different stages of life. Stars are born, they develop, and they die. They're born from a nebula, which if you remember back from a last section, a nebula is a cloud of gas and dust. And the sun is thought to be in middle age, so it has about 5 billion years left. Here's our star life cycle. You don't need to write these down, just to give you an idea of kind of what a star will go through. Mainly the ones to know, star is born, so that's a nebula. Our stars now, most of them that you're looking at are kind of in midlife. We have red giant after that, and that's one thing that you'll need to know. And then white dwarf after red giant. Those are kind of the key ones to know. So nebula, star, red giant, white dwarf. If it is a really large star, you could go to a supernova. It can cause a black hole when it dies. So a star is formed from a nebula. It collapses inward, spins faster and faster. The center of the core increases in temperature and nuclear fusion begins. A dying star is when fusion starts to slow down, so the pressure in the core drops and the core will contract on itself, causing core temperature to rise. A red giant, this is one of the ones I said you need to know, is a large reddish star that's late in its life cycle. Eventually, our sun will become a red giant. And then eventually it will become a white dwarf. That's in 5 billion years, so we got some time. A white dwarf is a small, hot, dim star that is the leftover center of an old star. It's not fusing any elements anymore, and most of the stars in our galaxy will end as white dwarfs. Just to show you kind of what that would look like. Supergiant stars are massive stars, and they have hotter cores. They fuse heavier elements, and when they stop, they actually cause a shock wave, and it can cause a bright explosion when they die. A supernova is a gigantic explosion from the collapsing of a massive star, and these can cause neutron stars or black holes. A black hole is an empty space kind of, where the gravity is so intense that even light can't escape. So we can't see these directly because there's no light coming from it, and they have a very strong gravitational pull. All right, this next part you need to know, you're going to be need to be able to make and read an HR diagram. These are called HR diagrams or Hertzsprung-Russell diagrams. Page 673 in your book has a good example. Basically, these just show life cycles of stars. They show, you can kind of chart them on this graph and you can see where a star is in its life cycle. The vertical axis is brightness, the horizontal axis is surface temperature. When the stars are born, they appear as protostars on the chart, and the position of the star will change as they go through their life cycle. So red giants are in the upper right. White dwarfs are in the lower left. Here's an example of what one would look like. So notice white dwarfs are down here, red giants are up here, and then the main sequence is midlife. And notice the sun is in midlife. Here's another one, another way it can look. And basically when you document these or graph them, you're just putting the dot there where something would be. And the sun is in the main sequence, which is midlife. That's it for stars and star life cycle. You'll be practicing some of these on some worksheets in class.